I'm Stephen Krause with Ixis Colorado, and I'm joined this morning by Bob Schmidt. I'd like to welcome everybody to our PCO-7114-50-4 informational webinar. This webinar is being recorded, and I do want to make sure now that everybody can hear the audio and see the video and the presentation. If you can hear the audio and see the presentation, if you could just type that into the chat real quick, that would help us make sure that everybody's getting the information they need. In the chat function, please go ahead and use it at any time to ask a question or ask for us to speak up or maybe lower the volume depending on what your experience is. Just let us know. Throughout the presentation, you're welcome to, as I said, put questions into the chat. We will have a dedicated Q&A session at the end. And at that time, you're welcome to ask any questions you want. If you have questions that you're not comfortable asking publicly, that's fine. You can email us at support@ixiscolorado.com or sales@ixiscolorado.com, or you're welcome to give us a call. So without further ado, I'd like to talk a little bit about what we're going to cover this morning. And so we're going to overview what is the PCO-7114-50-4. What's in the box? What are you going to get when you purchase one? What accessories and replacement parts are available? What markets and applications are appropriate for the PCO-7114? And then we'll start a technical overview, and Bob will take over at that point, and he will discuss how to set up the unit, some solutions to common problems, and then I'll switch back and start talking a little bit about price and availability. And then I'll do a quick introduction to our Lab to Launch program, and we'll have a question and answer session. So, without further ado, let's go ahead and get started. So the PCO-7114-50-4 is a fixed width pulsed laser diode driver. It's open frame, which means it's a printed circuit board only, which allows it to be easily implemented or integrated into another system. So it's a very good module for designing a system around that needs pulsed laser light, and then you can integrate it, mount it into your own system in your own box, and you don't have to worry necessarily about how to pulse or how to drive the laser pulse, just the part of the project that you're an expert in. So it's designed specifically for that application, for OEM applications being designed into a product, and we want to help you focus on your core product and let us worry about creating a pulse. So what's in the box? The PCO-7114-50-4, obviously, the manual, and the PCA-9190 control cable assembly, and that allows you to control the unit. And the setup Bob will talk about here in a little bit. This is just a couple of views, the top and the bottom of the printed circuit board, so just for reference. Accessories and replacement parts. So the PCA-9190 control cable, which is included with the unit, you can buy separately. The 1820-0030 output strip line is sold separately in the event that you need to connect the PCO-7114 to a diode that is not directly mounted onto the printed circuit board. And Bob will cover a little bit of that when he discusses the setup and the use. The PCA-9140 current monitor cable allows you to have a signal that monitors the current output of the unit, so that you can compare that maybe with your optical power output and make sure that your system is operating like you would expect. The markets that we've seen success in this kind of module are the automotive market, science and experimentation markets, test and measurement, construction, defense aerospace, topography and mapping, forestry, oil and gas exploration, and even archaeology. And as you know, and most of these are LiDAR or ADAS applications, and LiDAR applications for LiDAR and that kind of technology are exploding. And there's a lot of opportunity out there for new applications of lasers in mapping and and vehicle control and safety for automated vehicles. And so that's where this device is targeted for, and also the range finding market. Finally, at this point, I'd like to turn over the presentation to Schmidt, our application support, and we'll go from there.
Greetings, I'm Bob Schmidt, an application engineer here at IXIS, Colorado. Feel free to contact me at any time with your email questions or phone calls. Let's talk technical. This is a product that provides both high current pulses up to 50 amps and very fast pulses with rise times in the sub-2 nanosecond range. The output is a fixed width pulse, and it varies a little bit with the amount of current. As you can see, it's less than 5 nanoseconds for output currents below 20 amps and less than 4 nanoseconds at higher currents. The way you adjust the output current is by adjusting the voltage of a high voltage power supply. High voltage in this case meaning 0 volts to 180 volts, actually just a little bit less, as we'll see in a moment. As you increase that voltage, the output current will increase. The trigger needs to be a logic level that goes from 0 volts to 5 volts. It's commonly referred to as TTL or CMOS levels. Your driver has to be capable of driving 50 ohms. That's a requirement that professional function generators can provide, but if you're doing your own logic or microprocessors, you may need a buffer in between. Finally, we have a current monitor circuit, which is actually a very good option because it gives you a very good rendition of the pulse that's going to the laser diode. You will have to set your oscilloscope for 50 ohms to make use of the current monitor and have the correct scaling. The scaling is 1 volt per 20 amps. So a 1 volt pulse on your oscilloscope represents a current of 20 amps flowing in the laser diode. These are the packages that we can handle with the whole arrangement on the PC board itself. If you need to mount the laser diode remotely, you can use a little bit of micro stripline cable, which we supply. However, it's not recommended that you go very far. The inductance in that circuit will tend to modify the pulse. This chart shows the maximum frequency versus the amount of current. As you can see, our maximum frequency is about 650 kilohertz, and that's at 5 amps of current. By the time we get out to 50 amps, the maximum frequency is perhaps down in the 50 kilohertz range. And this is done without any cooling. This chart shows the voltage value of your external power supply versus the amount of current. As you can see in this chart, which is a typical chart, not necessarily guaranteed, by the time you get to about 160 volts, we are running maximum current. And when you set the voltage down to somewhere below 40 volts, you'll get about 5 amps of current. And it's a reasonably linear line. Here's our setup. On the left is our oscilloscope. The white box is what you get from IXIS, Colorado. And on the right side are 3 pieces of gear. The top one is a function generator. We're using that to generate our 5 volt pulses. The middle box is a low voltage DC power supply, which we're going to set to 24 volts. You don't need very much current. And the bottom unit is the high voltage power supply. When we open up the white box, we find a manual, a control cable, a little anti-static box with the PCO-7114 in it, and if you've ordered the optional current monitoring cable, that will be supplied as well. Inside the box is our little pulsar. As you can see, it's not very large, takes up very little room inside your OEM product. This shows the control cable attached. The control cable is not keyed. It needs to be inserted correctly onto the male pin connector on the board. And the way it works is our ground connections, or the black wires, are on the right-hand side, and the hot wires are on the left-hand side. You'll need a wire strippers to remove the insulation from the ends of the 3 pairs of wires. Here we have connected our red and black wires to our 24-volt DC power supply. Here's a little adapter that we're using to adapt the BNC connector on our function generator to the orange and black wires. And finally, we connect our high voltage power supply to the blue and black wires. Obviously, we have to insulate those. We don't want anybody to get shocked. The finished connection looks like this: 3 pairs of wires going to our function generator, our low voltage supply, and our high voltage supply. A couple of notes. First of all, the circle on the left is there to illustrate the fact that we are driving a short circuit day. These are current sources. It does not harm the product to drive a short circuit. So we've put a piece of solid 22 gauge wire shorting the anode and cathode terminals of the laser diode, and we will use that to get our base pulse. The arrow is pointing to the green wire of the current monitoring cable, which is the ground wire. So when you plug that connector in, we want the green wire to be close to the MOSFET on the right and the resistor to be on its left. Finally, the arrow on the right is pointing to the blue wire. We want to make sure that you've plugged that into pin 10 of the connector, as you see it here. If you connect this connector reversed, you will not damage the board, but of course you will get no output. Here's our setup. We've adjusted our power supply at the bottom, the high voltage supply, to 150 volts. We've set our DC lab supply to 24 volts, and we've got our function generator set to 10 kilohertz, just a number we picked for demonstration purposes. And there's our pulse. We've put a red circle near the bottom of the screen to illustrate 2 things. First of all, we need to have our scope set for 50 ohms input impedance. On this scope, it's done by just pushing a button. On your scope, it may be that simple, or you may need a 50 ohm terminator, which is a small cylindrical device that plugs into the BNC connector, and then the current monitor cable plugs into it. But we need to have a 50 ohm termination on the scope to get a proper pulse. The other thing we have going on here is we have inverted the oscilloscope trace so that the pulse looks positive. In reality, if you don't do that, the pulse will appear negative going. It doesn't matter. It's a mirror image in either case, but it looks a little more understandable to see the pulse as a positive waveform. What if we have problems? Well, the answers are fairly obvious. First of all, make sure that you've got the anode and cathode of the laser connected properly. Make sure the 2 connectors are inserted correctly. Neither one is keyed. So review our video if you need to. Make sure your trigger source is capable of driving a 50 ohm load. In other words, it needs to be capable of driving 100 milliamps into 50 ohms. Have you turned on your 24 volt power supply and your high voltage power supply? And finally, have you turned on the trigger source, the function generator, or whatever logic is being used to trigger the board? If you have reduced output or ringing, sometimes referred to as overshoot and undershoot on the pulse, in other words, the pulse doesn't look like the one we just showed you, number 1, make sure the connections are solid. Number 2, make sure you haven't exceeded the maximum frequency for the amount of current that you're asking for, and that goes back to the chart we discussed a moment ago. And finally, inductance and resistance are crucial that we minimize those. If you're mounting the laser diode directly on the board, which is the preferred method, you won't have any problems. If you use a very long piece of strip line, or if you skip the strip line and simply use wires to connect the pulsar to the laser diode driver, you will probably suffer from a rather poor looking pulse.
Okay, thank you, Bob. Bob will be around for questions also if there are technical questions a little bit later. And but I want to wrap up talking about the price and availability. And like I said earlier, I want to do a brief overview of the Lab to Launch program, which is designed specifically around this type of product. So the manufacturer's suggested retail price of the PCO-7114 is $147. That's U.S. pricing. Outside the U.S., there are things that are outside of our control. So if you're an international customer, you may see a slight deviation from that based on like taxes, tariffs, import duties, and other things that impact costs like that. So I want to talk a little bit about the Lab to Launch program, and we do have a complete overview of Lab to Launch on our website and on our YouTube channel, so I'm not going to go into a lot of detail, but I do want to introduce it so that everybody knows that it exists. The Lab to Launch program is specifically designed for us to provide customers with support from the very beginning of a project until it's complete, until the integration of a custom OEM module into their finished product. And we start with our systems products, which are benchtop systems, which have more variability and more capability than a module might, but those allow you to do experiments throughout a wider range and using a wider range of controls, computer control or manual control, so that you can establish what the project or what your final product really needs in terms of a pulsar. And then we can go back and design a specific solution, whether it's the PCO-7114 or a modified version of it, or even a completely unique product, or one of our other modules. And so the idea is to get involved with the project as soon as possible. And so I encourage you guys, when you have a project that's going to incorporate a pulse laser diode driver, give us a call as soon as you know that you have a project, and work with us to come up with this, because we can save our customers time and money by implementing our expertise to help you get the results you want without you having to go back and forth with experiments that we could help you avoid. So I just wanted to introduce that. It allows us to help you focus on your core product. Let us worry about the pulse, like I said a little earlier. And so at this point, I just want to open it up to questions. You're welcome to put any questions you want into the chat. As I said earlier, we will, if there are questions that you don't feel comfortable asking in an open forum, that's fine. Contact us at support@ixiscolorado.com or sales@ixiscolorado.com. We'd be happy to answer those as well. I know it takes a little bit of time to get to type into the chat, so there may be a few minutes of quiet time, but we will be here for a little while until it's very clear that all the questions have been answered. In the meantime, why don't you go ahead and switch the video back on, and while people are typing away, I will go through, and I kind of want to show the evolution of the 7114. So here we have a 7114. Is that showing up okay? And this is a successor product to our 7110, which you can see here. And if you're familiar with the 7110, you'll notice that the 7114 is a little bit larger, and it probably will be kind of hard to see, but the 7114 is quite a bit thicker. Is that even showing up at all? Not really. And the reason for that is we wanted to improve reliability for the 7114, and by making the board thicker, we've improved its reliability, and also we've allowed for more spacing around some components to provide better cooling and better mechanical performance. So I just wanted to kind of go over that. You can go ahead and switch back to the avatar, but that's what those look like. And do we have any questions coming up? It doesn't look like we have any questions coming up. So if you have questions, we're happy to answer them. Otherwise, we also want to respect everybody's time. So it looks like we do have a question coming up. And the question is, can the configuration be changed to permit different pulse widths? Bob, do you want to address that?
It cannot. It is a fixed pulse width, It tends to vary a little bit with the output current, but the design is for a very, very fast pulse. It consists of one rise time followed by one fall time.
So it's variable frequency. And
variable frequency, and of course we have other products that have variable pulse widths.
Right, right. We can certainly address a variable pulse width requirement, but that's not the target market for the target condition for the PCO-7114. Does that answer the question? Okay. I don't see any other questions coming up. Like I said, we're happy to answer any that anybody have. But before I let you go, I'd just like to say again, thank you for joining us this morning. And we will be posting this on our YouTube channel. So if you need to view it again or you want to send a link to a colleague, that'll be available later today. And thanks again. We look forward to working with you.